Deep learning is a branch of machine learning which is based on artificial neural networks. It is capable of learning complex patterns and relationships within data. In deep learning, we don't need to explicitly program everything. It has become increasingly popular in recent years due to the advances in processing power and the availability of large data sets. Because it is based on artificial neural networks, ANNs, also known as deep neural networks, DNNs. These neural networks are inspired by the structure and function of the human brain's biological neurons, and they are designed to learn from large amounts of data. Deep learning is a subfield of machine learning that involves the use of neural networks to model and solve complex problems. Neural networks are modeled after the structure and function of the human brain and consist of layers of interconnected nodes that process and transform data. The key characteristic of deep learning is the use of deep neural networks, which have multiple layers of interconnected nodes. These networks can learn complex representations of data by discovering hierarchical patterns and features in the data. Deep learning algorithms can automatically learn and improve from data without the need for manual feature engineering. Deep learning has achieved significant success in various fields, including image recognition, natural language processing, speech recognition, and recommendation systems. Some of the popular deep learning architectures include convolutional neural networks, CNNs, recurrent neural networks, RNNs, and deep belief networks, DBNs. Training deep neural networks typically requires a large amount of data and computational resources. However, the availability of cloud computing and the development of specialized hardware, such as graphics processing units, GPUs, has made it easier to train deep neural networks. In summary, deep learning is a subfield of machine learning that involves the use of deep neural networks to model and solve complex problems. Deep learning has achieved significant success in various fields, and its use is expected to continue to grow as more data becomes available and more powerful computing resources become available. What is deep learning? Deep learning is the branch of machine learning which is based on artificial neural network architecture. An artificial neural network, or ANN, uses layers of interconnected nodes called neurons that work together to process and learn from the input data. In a fully connected deep neural network, there is an input layer and one or more hidden layers connected one after the other. Each neuron receives input from the previous layer neurons or the input layer. The output of one neuron becomes the input to other neurons in the next layer of the network, and this process continues until the final layer produces the output of the network. The layers of the neural network transform the input data through a series of nonlinear transformations, allowing the network to learn complex representations of the input data. Today, deep learning has become one of the most popular and visible areas of machine learning due to its success in a variety of applications such as computer vision, natural language processing, and reinforcement learning. Deep learning can be used for supervised, unsupervised, as well as reinforcement machine learning. It uses a variety of ways to process these. Supervised machine learning. Supervised machine learning is the machine learning technique in which the neural network learns to make predictions or classify data based on the labeled datasets. Here, we input both input features along with the target variables. The neural network learns to make predictions based on the cost or error that comes from the difference between the predicted and the actual target. This process is known as backpropagation. Deep learning algorithms like convolutional neural networks, recurrent neural networks are used for many supervised tasks like image classifications and recognition, sentiment analysis, language translations, etc. Unsupervised machine learning. Unsupervised machine learning is the machine learning technique in which the neural network learns to discover the patterns or to cluster the dataset based on unlabeled datasets. Here there are no target variables, while the machine has to self-determine the hidden patterns or relationships within the datasets. Deep learning algorithms like autoencoders and generative models are used for unsupervised tasks like clustering, dimensionality reduction, and anomaly detection. Reinforcement machine learning. Reinforcement machine learning is the machine learning technique in which an agent learns to make decisions in an environment to maximize a reward signal. The agent interacts with the environment by taking action and observing the resulting rewards. Deep learning can be used to learn policies or a set of actions that maximizes the cumulative reward over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic policy gradient (DDPG) are used to reinforce tasks like robotics and game playing, etc. Artificial neural networks are built on the principles of the structure and operation of human neurons. It is also known as neural networks or neural nets. An artificial neural network's input layer, which is the first layer, receives input from external sources and passes it on to the hidden layer, which is the second layer. Each neuron in the hidden layer gets information from the neurons in the previous layer, computes the weighted total, and then transfers it to the neurons in the next layer. These connections are weighted, which means that the impacts of the inputs from the preceding layer are more or less optimized by giving each input a distinct weight. These weights are then adjusted during the training process to enhance the performance of the model. Artificial neurons, also known as units, are found in artificial neural networks. The whole artificial neural network is composed of these artificial neurons, which are arranged in a series of layers. The complexities of neural networks will depend on the complexities of the underlying patterns in the dataset, whether a layer has a dozen units or millions of units. Commonly, artificial neural network has an input layer, an output layer, as well as hidden layers. The input layer receives data from the outside world, which the neural network needs to analyze or learn about. In a fully connected artificial neural network, there is an input layer and one or more hidden layers connected one after the other. Each neuron receives input from the previous layer neurons or the input layer. The output of one neuron becomes the input to other neurons in the next layer of the network. And this process continues until the final layer produces the output of the network. Then, after passing through one or more hidden layers, this data is transformed into valuable data for the output layer. Finally, the output layer provides an output in the form of an artificial neural network's response to the data that comes in. Units are linked to one another from one layer to another in the bulk of neural networks. Each of these links has weights that control how much one unit influences another. The neural network learns more and more about the data as it moves from one unit to another, ultimately producing an output from the output layer. Difference between machine learning and deep learning. Machine learning and deep learning both are subsets of artificial intelligence, but there are many similarities and differences between them. Machine learning applies statistical algorithms to learn the hidden patterns and relationships in the dataset, uses artificial neural network architecture to learn the hidden patterns and relationships in the dataset, can work on the smaller amount of dataset, better for the low-label task, takes less time to train the model. A model is created by relevant features which are manually extracted from images to detect an object in the image, less complex and easy to interpret the result. It can work on the CPU or requires less computing power as compared to deep learning. Deep learning uses artificial neural network architecture to learn the hidden patterns and relationships in the dataset. Requires the larger volume of dataset compared to machine learning. Better for complex tasks like image processing, natural language processing, etc. Takes more time to train the model. Relevant features are automatically extracted from images. It is an end-to-end learning process. More complex, it works like the black box interpretations of the result are not easy. It requires a high-performance computer with GPU. Types of neural networks. Deep learning models are able to automatically learn features from the data, which makes them well-suited for tasks such as image recognition, speech recognition, and natural language processing. The most widely used architectures in deep learning are feed-forward neural networks, convolutional neural networks, CNNs, and recurrent neural networks, RNNs. Feed-forward neural networks, FNNs, are the simplest type of ANN with a linear flow of information through the network. FNNs have been widely used for tasks such as image classification, speech recognition, and natural language processing. Convolutional neural networks, CNNs, are specifically for image and video recognition tasks. CNNs are able to automatically learn features from the images, which makes them well suited for tasks such as image classification, object detection, and image segmentation.